Hello, you are watching podcast 9.8 on compound events. We've talked about simple events up to this point, so now we're just applying more than one event happening at the exact same time, okay? So a compound event consists of two simple events, at least two simple events, and there's going to be two different types of compound events we're going to talk about to begin with. The first one is an independent event. This is the outcome of one event. The outcome of one event does not affect the outcome of another event. Okay? So for example, rolling a die and flipping a quarter. When I roll a die, it has nothing to do with the quarter that I am flipping. The outcome of the first event will not affect the outcome of the second event. A dependent event is the outcome of one event does affect the outcome of the second. Okay, so an example of that would be choosing a name from a raffle and not putting that name back before you draw the next name. Okay, so for a dependent event, usually they're going to talk about something about replacement. Okay, and in this problem, they're choosing a name from a raffle and not putting that name back in the raffle before you draw the next name. So there's no replacement. You're not putting anything back into it. When I pull a card out of the deck, I'm not putting it back into the deck. There's no replacement of anything. Okay, independent and dependent events can sound similar when you read it, but you need to think about, will my second probability be affected by the first? All right, and as we go through these, you'll see a little bit more about what we're talking about. So we're going to be doing compound events today, and then we'll combine this with a review later on, just of compound events and combinations and permutations to try to help you make sure you understand the process. Okay, so looking right here, change the font here. It says to solve an independent event, you're taking them separately. Probability of A times the probability of B. Okay, so for example, if I'm rolling a die, the probability that I would roll a 2 and then flip a quarter and then get heads. Okay, so this is an example. So the probability that I'm going to roll the first one, it would be 1 out of 6. Okay, so, oops, 1 out of 6. Hopefully this is going to work now. Times, then the probability you're going to roll B, or flip a heads, has nothing to do, once again, with what I roll, and that would be 1/2. And then you're just multiplying fractions. 1 times 1 is 1. 6 times 2 is 12. The probability you will roll a 2 and flip heads on your quarter would be 1/12. That's how you figure an independent event. A dependent event is the outcome of one event does affect the outcome of the second. So choosing a name from a raffle and not putting that name back in before you draw the next name. Okay, so you're finding the probability of A and B. You would still multiply probability of A, but the probability of B is going to be slightly affected by the probability of A. So for example, choosing a name from a raffle of 12 students and not putting that name back in before you draw the next name. So the probability of the first that you are going to be chosen would be 1/12. But my next probability would not be out of 12 anymore. Now it's going to be out of 11. 1 out of 11. Okay, so see how that's affected? The denominator in this case is affected by the first event. That's why it's dependent. So it's not going to be 1/12 times 1/12. It's going to be 1/12 times 1/11 because that's how many names are left in the raffle. Okay, and that would be 132. Okay, so found in the same way, you're still multiplying fractions. Okay, you're just trying to understand and see if the first event is affected by the second. And if it is, it's a dependent event, meaning that the second fraction is going to be changed slightly due to the no replacement that is occurring. A disjoint event are events that cannot happen at the same time. Okay, so tossing either heads or tails on a coin, they can't happen at the same time. It's impossible. Okay, so they have to happen at two separate times. So to find a disjoint event, you're looking for the word or. Here it is. So the probability of getting A or B, it would be probability of A plus the probability of B. So it's very different. It's going to be different types of problems than independent and dependent. We're doing one or the other, not and the other, like the other two had said. Okay, so you're going to add the two fractions together. Now remember, when you add fractions, you have to have a common denominator. Okay, so we don't have to worry about that with multiplying, but when I add fractions, they do need to have a common denominator. Okay? So let's begin some of these problems, and we'll discuss as we go whether they're independent, dependent, or a disjoint event. Okay? So a spinner is spun and a number cube is rolled. Find each probability. So the probability of 4 and a consonant. It says and, so I know it's going to be independent or dependent. And because I'm spinning a spinner and I'm rolling a number cube, you know one is not going to affect the other. So this is an independent event. So to find my independent event, I'm going to find the probability of rolling a 4, which would be 1 out of 6, times the probability of spinning a consonant. Now if you look at my spinner, there are 3 sections, so 3 outcomes, and C and B are my consonants. So to multiply them, 1 times 2 is 2, 6 times 3 is 18, and as always, in a fraction, if I can simplify it, I need to do so. So I'm going to simplify this to 1/9. So the probability of rolling a 4 and spinning a consonant is 1 out of 9, 1/9. For lunch, Jessica may choose a turkey sandwich, a tuna sandwich, a salad, or a soup. To drink, she may have juice, milk, or water. If she chooses a lunch and a drink at random, what is the probability that she would choose a sandwich and a juice? So once again, it's and. And what sandwich I choose has nothing to do with what drink I choose. Maybe one goes together with the other, but it's not going to affect the other's probability. Okay, so this once again is an independent event. Here's my pen going psycho on me again. Independent. Come on now. Well, you're going to have to write the word event because apparently I cannot. There we go. Okay, so we're going to find the probability she chooses a sandwich. Well, I have a turkey sandwich, a tuna sandwich, a salad, or a soup. So there's 4 different ones I get to choose from. And tuna and turkey sandwiches. So there's 2 sandwiches. So 2/4 is the probability that I will get a sandwich, or 1/2. Either way is fine. And the probability I would choose a juice. So I'm choosing from juice, milk, or water. So that's 3 outcomes, 3 possibilities, and only one of them is juice. So I'm going to multiply them together. 2 times 1 is 2. 4 times 3 is 12. And I can simplify this as well to get 1/6 as my answer. You'll notice that I could have just written this as 1/2, which is its simplified form, and I would have gotten 1/6 as well. So whether you simplify it or not in the beginning is not important as long as your answer is simplified. Okay? Once again, independent because one does not affect the other. All right, on this one, there are 4 black, 6 white, and 2 blue socks in a drawer. Joe randomly selects 2 socks without replacing. That part's very important. The first sock. What is the probability that he selects 2 white socks? So we want the probability. Come on, pen. All right, I'm going to have to bring it down here, right? Probability of getting white and white. Now looking at this problem, it says Jose randomly selects 2 socks without replacing the first sock. So I'm not replacing it, meaning it's going to be a dependent event, which means my second fraction will be affected by the first. Okay? So I need to count up my total socks. 4 plus 6 is 10 plus 2, so I have 12 socks to choose from. Okay, so the probability it's going to be white would be, first of all, it's out of 12. How many white socks do I have? I have 6 white socks. Times, now I've taken one out of the drawer, so I only have 11 socks left. But since I'm finding the probability of another white sock, I've also taken the first white sock out of the drawer, so I only have 5 white socks left. So you'll see how the numerator and denominator can be affected by the dependent event. If I take one sock out, I only have 11 socks left. And if I take a white sock out, I only have 5 white socks left. So I'm going to multiply across. 6 times 5 is 30. 12 times 11 is 132. And I'm going to simplify here. And I can reduce by 6 actually. 30 divided by 6 is 5. 132 divided by 6 is 22. Okay, and once again, if you wanted to simplify this to 1/2 to begin with, that would be fine as well, and you would still get 5 out of 22. So the probability that he selects 2 white socks would be 5 out of 22 tries. And the last one, a month of the year is randomly selected. What is the probability of the month ending in the letter Y or the letter R? So it's probability of Y or R. Since we have the word or, we know this is a disjoint event. And when we have a disjoint event, we are not multiplying the probabilities, you are adding. Okay? So probability of the month ending in the letter Y or R. So first of all, we know there's 12 months. 12 months. The numbers ending in Y would be January, February, March does not, April does not, May does, that's 3, June does not, July does, that's 4, August does not, September does not, October does not, November does not, and December does not. So 4 out of 12 end with the letter Y. Now I'm going to keep it as 4/12 and not simplify because I need a common denominator. And because I need a common denominator, I'm talking about months. We know the second one will be out of 12 as well. Okay, so don't simplify it. So now I need my months that end in R. So I have January, February, March, April, May, June, July, August, September, that's 1, October, 2, November, 3, and December, 4. Okay, so 4/12 plus 4/12 is 8/12. Remember, your denominator stays the same. And now I will simplify. Oops, I can simplify it by 4, so that's what I'm going to do. And it's acting up again. Just be patient with me here. Okay, so I get 8 divided by 4, which is 2. 12 divided by 4 is 3. So 2/3 is the answer. Okay, so the probability that you're going to get a month that ends in Y or R is 2 out of 3. Okay, this section, it takes some work. It's going to take you, once again, reading through the problem, understanding what type of problem it is. Remember, if you are joining events and, using the word and, it's going to be independent or dependent. If you're using the word or, it's going to be a disjoint event, meaning you're not going to be multiplying like you do for independent and dependent. You're going to be adding. Okay, read through the problems very carefully. Make sure you're thinking of all options and whether one is being affected by the other. Okay, if you need to watch again tomorrow, please feel free to do so. If you have any questions as you're going through, make sure you ask Mr. Kohlinger or I as well. Thanks for watching.